Okay, what we want to do in this next video, continue talking about factoring, but we're getting toward the end of all these videos we've been doing since section 5.5, all on factoring, but we're going to wrap this up probably within the next two videos. So what we want to talk about now is something we've not talked about, is how do we factor binomials and what binomials factor? Because see, not all binomials factor. Okay, but before I say what I'm about to say, let me say this. When you factor any binomial, when you factor anything, period, but when you factor binomials, since that's what we're talking about here, what is the first thing you always look for? GCF, always. So understand that what I'm about to talk about still comes behind you checking for a GCF. That always comes first. So if a binomial has a GCF, does it factor? Yes. But what I'm talking about is factoring binomials farther than just GCF. Well, it turns out that in binomials, there's two ways you can factor binomials. And by the way, and this is after GCF. And by the way, let me go back just a second. If you noticed, trinomials, there's three things you have to watch for after GCF. What were the three things you have to watch for with trinomials? Easy case, perfect square trinomial, Brew method. Those are the three cases with trinomials after GCF. Well, with binomials, there's two ways binomials will factor after GCF. I'm going to give you the names of both of them. I'm just going to do one at a time, though. I'm going to give you the name, and then I'll show you how it factors. One is you ask yourself, is it the difference of two perfect squares? Is it the difference of two perfect squares? So let me go ahead and say it, and then I'll show you why. If it is the difference of two perfect squares, it will factor. If it is the difference of two perfect squares, if the answer to this is yes, then it will break up, and you can factor it. Now, how can I tell if the answer to this is yes? All right, let's break this down and I'll show you. First of all, how many terms is going to be in it? 2. Now, what are both of these terms? It's a binomial. What are both of these terms going to have to be? Perfect squares. So the first term's got to be a perfect square. The last term's got to be a perfect square. Here's what makes it different. The sign that's in between those two perfect squares has to be the difference. In mathematics, what does the word difference mean? It means subtract. Like if I said, what is the difference between 9 and 6? It would be 3. Now, what if I said, what is the sum of 9 and 6? That would be 15. So the word difference means subtract. So here's what these problems are going to look like. It's going to be two terms. This is going to be a perfect square. This is going to be a perfect square. Both of them will be perfect squares. And then the sign in between them has to be a minus. Must be a minus. The difference of two perfect squares. I will explain in just a minute why it has to be difference. All right, so let me just show you a couple that are difference of two perfect squares. You don't have to write these down. All right, watch. Is this the difference? Yes. Of 2? Yes. Perfect squares. X and X, 3 and 3. Yes, that's the difference of two perfect squares. Is this the difference of two perfect squares? Yes. The difference, two terms, perfect square, 2x, 2x, 49, 7 and 7. Now, at this point, if it is a binomial and it doesn't have a GCF, and it's not a difference of two perfect squares, we will call it prime. So don't start inventing ways. So if I put up a problem that is not the difference of two perfect squares, we don't have any other method right now. So we're just going to call it prime. So let me show you an example. If I write this, is this the difference of two perfect squares? No, because that's not a minus. Now, I'm going to show you in a minute why this one doesn't factor. But if it's not the difference of two perfect squares, we call it prime. So, are these perfect squares? Yes. Is it two terms? Yes. But it's not difference. Let me show you another one. I know this one has a GCF. We'll talk about that in a minute. But is this the difference of two perfect squares? No. Because this is a perfect square. This is difference. But 10 is not a perfect square. You say, well, 10 is 5 times 5 and 5. No, 5 times 5 is 25. So this is not the difference of two perfect squares. So this is what the difference of two perfect squares looks like. Now, let me show you how it factors. And of all the factorings that we've done, the difference of two perfect squares is definitely the easiest. So, as the instructions has been saying, factor completely. All right, so let's write this one down. And I know you get tired of hearing me say this, but the more times I say it, the more times it will stick. All right, so the first thing I look for, when I look at that problem, the first thing I look at is, I say to myself, it's got two terms in it. What's the first thing we look for in any factoring problem? GCF. So does this have a GCF? No. So that's out. Now, do I have to worry about grouping? No, grouping's 4 terms. Do I have to worry about the easy case trinomials? No, that's trinomials. What about the Brew method? No, that's trinomials. What about perfect square trinomials? No, that's trinomials. So all the stuff we've talked about up to this point is not even applicable in this problem. So after you look, if it's a binomial, after you look for GCF, there's only one question you have to ask yourself. Is it the difference of two perfect squares? Is it the difference? Yes. Of 2? Yes. Perfect square, 2x, 2x. 25 is 5 and 5. So yes, that is the difference of two perfect squares. Watch how easy this is now. Do your 2 sets of parentheses. 4x squared is 2x and 2x. 25 is 5 and 5. And remember, this minus means the signs are different. It does not matter whether you put the plus first or the plus second, as long as one's plus and one's minus. Now, let me show you that this works. Let's FOIL it out to check it. 4x squared minus 10x plus 10x, look at that, and then minus 25. The 10x's add out, and that takes me right back to where I started. That's how you factor the difference of two perfect squares. Okay? Let's do another example. Let's do this one. 49 minus 16 m squared. Okay, here we go. First, does it have a GCF? No. Next, is it the difference? Yes. Of 2? Yes, 2 terms. Perfect square, 7 and 7. 4m and 4m? Yes. Now, because the 49 is first, you have to put the 7s first. So it would be 7 and 7, 4m and 4m. And one's got to be a plus, one's got to be a minus. Always, one will be plus, one will be minus. Okay? Another one. 36 minus x squared. The difference, back up. GCF? No. Next, the difference, yes. Of 2, yes. Perfect square, 6 and 6. Perfect square, x and x. And let me tell you one more time. You say, well, Mr. Rayner, what if it doesn't have a GCF and what if it's not difference of two perfect squares? At this point, we would call it prime or non-factorable. So 6 and 6, x and x, one's plus, one's minus. Okay? 4x squared minus 25y squared. GCF? No. The difference? Yes. Of 2? Yes. Perfect square? 2x, 2x. Perfect square? 5y, 5y. One's a plus, one's a minus. Now, let me show you right quick this. X squared plus 9. Okay, first, does it have a GCF? No. Next, is it the difference of two perfect squares? No. And the reason it's not is because this is a plus. So what did I say just a second ago? If it doesn't have a GCF and it's not the difference of two perfect squares, what do we call it? Prime or non-factorable. Well, this problem is prime then. There are no two things you can multiply together to give you this. So go ahead and write now prime or non-factorable. Now here's what I want to show you. I want to show you the answer that I see so many times on this. And I'll show you why it's wrong. Now you agree with me. This is not difference of two perfect squares because that's a plus. So this problem is prime. But let's play dumb and let's go on through this. So let's suppose we did this. X squared is x and x. 9 is 3 and 3. Now let's suppose now, because this is a plus 9, you put pluses there. I can't tell you how many times I see this. This is wrong to the nth degree. Let me show you why it's wrong. Watch what happens if I multiply this out. X squared plus 3x. Then come back, plus another 3x, and then plus 9. You get x squared plus 6x plus 9. You don't get the original problem. So see, that's not right. And you say, oh, I know how we can fix it. Make this one a plus and this one a minus. If you do that, this would be negative 9 then. And that's not a negative up here. So that's why it has to be the what? Difference of two perfect squares. So if they're perfect squares and it's a binomial, it has to be a minus in between the two. So you say, okay, Mr. Rayner, I've got it. So if this is a plus and it's a binomial, it's prime every time. No. Here's why. Look at this problem right here. You say, well, Mr. Rayner, why isn't this prime? Because it's not the difference of two perfect squares. You just told me that this has got to be a minus. I did. Well, then why isn't this prime? What do you look for before you check for difference of two perfect squares? You look for a GCF. This problem has a GCF. So GCF always comes before anything else. So what's the GCF between 4x squared and 36? 4. So the fact that this has a GCF means that it cannot be prime. So take a 4 out, and I'm left with x squared plus 9. Now, it doesn't factor again because that's a plus. So it doesn't factor again, but if it has a GCF, I don't care what that sign is. If it has a GCF, it can't be prime. All right, let's look at this one. 18x squared minus 50. Okay. What's the first thing we look for? You said, well, this is not difference of two perfect squares. And you're right, by the way. But I'm not even supposed to be thinking that. What I'm supposed to be thinking right now is GCF. So this is not difference of two perfect squares. But I don't need to be checking for that now. So the GCF here is 2. If I take a 2 out, 2 into 18 is 9x squared minus 2 into 50 is 25. But remember, the instructions doesn't say factor. What does the instruction say? Factor what? Completely. And remember, I said this multiple times. When you take out a GCF, before you abort that problem, before you leave it, you look at what you have left and see if it'll break down again. Because if it does, and you don't factor it again, you don't get credit for that problem. So, does this factor again? Well, it's a binomial. We've already done the GCF. So what's the only other thing we have to check? Difference. 2. Is that a perfect square? Yes. 3x, 3x. Is this a perfect square? Yes. 5 and 5. So see, this breaks down again because it's difference of two perfect squares. Did it start out being difference of two perfect squares? No. But after I took the GCF out, it was. So factor this again. 3x, 3x, 5 and 5. One's a plus, one's a minus. But don't forget that 2 is just as much of the answer as the 3x plus 5 and the 3x minus 5. So now the problem is completely factored. So always check for GCF before you do difference of two perfect squares. All right, let's do 2 more. (9x squared minus 81). Now, this one is a little unique for a couple of reasons. First of all, because it's the difference of two perfect squares. But it also has a GCF. Now remember, in mathematics, order matters. When you do something, the order in which you do it. So GCF always comes first. So if you do the difference of two perfect squares first, you're not going to get full credit for this problem. GCF first. Okay, what's the GCF between 9x squared and 81? The GCF is 9. Now, look, when I took the 9 out, is this the difference of two perfect squares? Yes. So that means it still will factor again. X squared is x and x, 9 is 3 and 3, and one's a plus, one's a minus. Don't forget to bring the 9 down. So this one was a difference of two perfect squares and GCF. But you have to do it in the right order. GCF always first. Okay, one more example here. 5x squared minus 20x. First, look for a GCF. Now, if you're not careful right here, you'll say that the GCF is 5. That is not correct. Your GCF is 5x. Now, divide 5x into 5x squared, and I'm left with x, minus 5x into 20x just leaves 4. And you said, wait a minute, this right here breaks down again. No, it doesn't. because this is the difference of two terms. 4 is a perfect square, 2 and 2, but this is not a perfect square. So that does not break down again. So that's as far as that problem will go. So factoring binomials, there's two things that we watch for: GCF and difference of two perfect squares. Now, if you'll remember, I began this lecture by telling you, let's see if I've got it still here. Yes. I began this lecture by telling you that when we factor binomials, there's two ways. The first way was difference of two perfect squares. There's actually one other thing that we have to check for in binomials. So we're going to look for GCF, and then after that, there's two things we ask ourselves. One, is it the difference of two perfect squares? Two, is our last method on binomials, and this will close us out on factoring binomials and factoring period in the next video. So next video, section 5.7, part 4, to wrap up factoring binomials.